New Japan Radio microwave sensors, how they work, what types are available, and how to use them. Hello and welcome. This is Vitor Ribeiro from New Japan Radio Europe. I'm Sales and Marketing Manager in the European headquarters of New Japan Radio in Frankfurt, Germany. In this session we are going to introduce New Japan Radio's microwave sensors. You will get an overview about how they work, what sensor types NGR offers, and how to use them. There are many types of microwave sensors, also known as radar sensors, available on the market. Proximity sensors are mainly of a continuous wave type, where a signal with a constant frequency is being emitted. As soon as an object is detected, the reflected signal has a different frequency, which enables the sensor to distinguish if the object is moving towards or away from the sensor. Frequency-modulated continuous wave-alike sensors transmit a frequency-modulated signal. The reflected signal has a delay in a frequency shift, which enables to determine the distance and the speed of the object. However, there is a decent amount of computing power required to calculate both values simultaneously, and most companies focus on one of the two values. Continuous wave sensors are mostly used to detect if an object is moving towards or away from the sensor. These products are based on the well-known Doppler effect and can be used in a wide variety of applications ranging from vending machines, which switch on the lights as soon as somebody is approaching, to intrusion alert systems for in- and outdoor usage. These sensors will detect moving objects only, and as soon as the object stands still, it will, in theory, no longer be detected. The FMCW-alike category of radar sensors can detect moving objects and return the distance of the objects. Some versions can even differentiate between moving and stationary objects and return their distances. These sensors allow the definition of a detection range, which makes them suitable for an area supervision in applications such as parking lot monitoring, intrusion alert, and perimeter security systems. There are many proximity sensor technologies on the market, but most of them have a huge disadvantage because they always need a visual or an acoustic connection to the objects they want to detect. For example, ultrasonic sensors always need air as a medium. Optical sensors and pyroelectric infrared sensors always need to see the objects. They all have one thing in common: they cannot be mounted in a hidden way, and you will always notice the existence of the sensors. This is not the case with radar sensors because they can be mounted in a hidden way behind many materials such as wood, glass, plastic, cardboard, or ceramic tiles. You will simply not see or notice the sensor's existence, but the sensor will always detect you. This gives you the chance to combine function and style and to give your customers a unique user experience. Radar sensors are almost immune against environmental conditions. Changing weather conditions, dust, dirty surface, and reflections will create problems for optical sensors. Changing temperatures and loud environments with a wide acoustic spectrum will impact pyroelectric infrared and ultrasonic sensors. Microwave sensors, on the other hand, are not impacted and will work reliably. This makes them the preferred choice for the object detection in harsh environments. When it comes to using a microwave sensor, there is one more decision design engineers need to make. They can get just the RF ICs, with or without an antenna, which outputs the so-called IQ mixer signal. This configuration offers the maximum flexibility, but at a cost that you need to develop the entire signal conditioning, means signal amplification and filtering, and in addition the software algorithms such as multi-stage FFTs and software filter. This is not an easy task and tends to be very time-consuming. On the other hand, you could use a digital radar sensor module consisting of an antenna, RF ICs, filter, and MCU with all software algorithms. All you need to do is connect the module to a power source and to a microcontroller's UART interface, and you are ready to go. The digital module will send its data via the serial interface and allows engineers to focus on the core application development itself. The sensor will handle all signal conditioning and output an information which is ready to use. The result is a rapid prototyping and a short time to market, just by using NGR's digital radar sensor modules. New Japan Radio develops and manufactures radar sensors operating at 10 and 24 GHz as digital as well as an analog version. Today we will focus on the 24 GHz digital microwave sensors. Please check New Japan Radio's website or contact our distribution partners in case you require information about analog interface microwave sensors. Digital microwave sensors are designed with ease of use in mind and incorporate all the necessary bits and pieces required for a reliable presence detection. It is a hassle-free approach where you do not have to deal with RF signals, signal conditioning, and software algorithms to detect the presence of an object. NGR4265 is a member of our digital microwave sensor lineup. It is a continuous wave Doppler effect-based sensor which will reliably detect the presence of a moving object in front of the sensor. It will not only detect a movement like a pyroelectric infrared sensor, but will additionally tell whether the object is approaching or moving away from the sensor. The maximum detection range for NGR4265 is 10 meters and makes it suitable for all kinds of near-range presence and movement detection systems. It is working at a frequency of 24 GHz and is compliant to regulations in the EU, US, Asia and Japan. NGR4265 can be controlled through a serial interface which enables a complete and easy-to-use setup of the module. All sensor commands are being transferred as plain text AT-style strings. Feedback and detection information will also be sent to the MCU through the serial interface. However, in case you want to simplify the software, you can use the standard power-on setup and get the approach-leave information via two hardware outputs indicating both conditions. The threshold sensitivity can be set either through an external voltage or in software, which gives you a great level of flexibility. NGR4265 offered a high level of flexibility and ease of use. However, NGR4266 will increase this flexibility even more with a richer command set in two sensor versions. The first one can be fully controlled through the serial interface, while the second version does not require a microcontroller at all and can be operated standalone by using an analog threshold sensitivity input and a CMOS output to indicate movements in front of the sensor. NGR4266 is smaller, more compact, and offers improved power settings, a so-called eco mode, which brings the average power consumption down to 3 mA at 3.3 volts. The detection range is defined by the antenna pattern and covers distances of 7, 10, 13 and 14 meters with different horizontal and vertical detection angles. If you do not want to use a microcontroller for the presence detection, you could use a non-UART version of NGR4266 in standalone mode. Here you can see an example of a simple light switch with external hardware timer where the light's on time and the range can be set via external potentiometers. Very easy and very low cost with the option of hidden mounting where nobody will even notice that there is a proximity sensor. This is a huge advantage compared to pyroelectric infrared, optical and ultrasonic sensors. The detection is totally hidden and does not give any chance for manipulation. This is an example of a very simplistic gesture control using sequences of approaching and leaving movements with the hand. In this example, the hand has to approach the sensor 2 times, moving towards and away from the sensor. Each movement has to be within a given time in order to be accepted as a valid gesture. Even though the example is very basic, it shows the detection sensitivity very close to the sensor. In this case, the distance from the hand to the sensor was approximately 10 centimeters. The green LED indicates the hand approaching the sensor, while the yellow LED indicates the hand moving away from the sensor. NGR4234BV is a more sophisticated radar sensor which is capable to identify up to 3 moving objects in a 20-meter range. Its main purpose is the detection of moving objects and to return the absolute distance of the objects in meter. The functionality is a subset of the radar sensor I'm going to explain in more detail on the next foils. NGR4234BW is even more enhanced, because it not only detects moving objects but also recognizes up to 7 stationary objects. The combination of both detection methods opens a wider range of applications and gives you more flexibility when it comes to system configurations. Like NGR4234BV, the maximum detection distance is up to 20 meters, and it comes with approvals for Europe, the United States of America, and Asia-Japan. Both members of the NGR4234 series come with the same hardware communication interface, requiring the MCU to offer a serial interface or bit-banging GPIO pins for the sensor setup and communication. Beside the UART lines, there are two additional hardware signals available. The DAT pin is a digital output indicating a detection result, and it could be used to wake up the MCU or to trigger an interrupt. The MON pin signals an error condition, and it can be used to have the MCU triggering a software reset of the sensor. Let's use NGR4234BW's command set as an example, since the difference is mainly the non-existing handling of the stationary objects information in the NGR4234BV's command set. The sensor can be controlled through the serial interface, using a sophisticated command set which covers the configuration of the operation modes such as power saving functions, detection range commands, and a continuous transfer of object distance information. Setting the detection range of the sensor is an important feature and enables an automatic area supervision where movements outside the specified range are simply ignored. NGR4234BW offers this feature for moving as well as stationary objects. Mounting multiple sensors in an area can be done without problems because of the integrated radio interference prevention function. But there are many more features implemented, and once all parameters have been set, they can be saved to an internal EEPROM, which will be reloaded after reset. Use cases for radar sensors are, for example, all kinds of presence detections for indoor-outdoor lighting systems, area or range monitoring of parking lots in front of EV charging stations, and a wide field of security equipment for intrusion detection and alert systems. All these applications benefit from a robust and reliable technology, with features such as hidden mounting and independence from environmental conditions. But there are more potential applications, and only your imagination and creativity will set the boundaries. Thanks for watching, and please feel free to contact New Japan Radio or a distribution partner in case you need additional information, samples, or technical assistance.